Calculus examples. The motion of a particle moving along a straight line. This is video 7. Application 2. Find the velocity function from the position function and then use them to find the velocity and the position relative to the origin of a particle at a given time. The following list of 7 short videos shows all videos, including this one, that involve the product rule to find the derivative of a function in an example or an application. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. Example: the motion of a particle moving along a straight line. The position of a particle moving along a straight line is given by the equation S equals t into t minus 6 times cos t, where S is measured in meters and t is measured in seconds. Only the first 7 seconds of the motion should be considered. A. Find the velocity function from the position function. B. What is the initial position and the initial velocity of the particle? Is the particle moving towards the origin or away from the origin? C. Find the position and velocity of the particle after 2 seconds of motion. Is the particle moving towards the origin or away from the origin? Solution. Part A. Find the velocity function from the position function. From video 5, the derivative of the position function S equals t into t minus 6 times cos t is S dash t equals 2 into t minus 3 times cos t minus t into t minus 6 times sin t. How to find and simplify this derivative is fully explained in video 5. It is not included here in order to reduce the length of this video. The derivative S-t finds the instantaneous rate of change of distance with respect to time, which is the velocity. So S-t will find the velocity of the particle at any point on the function st, provided the derivative exists at the point. Note that if you had to solve an example for homework which is similar to the example in this video, you would have to show how you found and simplified the derivative. Part B. What is the initial position and the initial velocity of the particle? Is the particle moving towards the origin or away from the origin? The initial position of the particle can be found by setting t equals 0 in the position function shown below. So st becomes s0 equals t becomes 0 times t becomes 0 minus 6 times cos t becomes cos 0 equals 0 times this expression is 0 meters. The initial velocity of the particle can be found by setting t equals 0 in the velocity function shown below. So s-t becomes s-0 equals 2 times t becomes 0 minus 3 times cos t becomes cos 0 minus t becomes 0 times t becomes 0 minus 6 times sin t becomes sin 0 equals 2 times 0 minus 3 becomes minus 3 times cos 0 becomes 1 minus 0 times this expression is 0 equals 2 times minus 3 times 1 is minus 6 minus 0 is minus 6 meters per second. So the motion of the particle starts at the origin. It moves away from the origin in the negative direction with a speed of 6 meters per second. To review the above calculations, you should pause this video now. Note that using the TI-84 calculator, cos 0 equals 1 and sin 0 equals 0. Part B. Diagram of the s-axis. The motion of the particle can be illustrated by using the s-axis as the straight line it moves along and then plotting the position and velocity of the particle on it. The maximum and minimum values on the s-axis can be found from the graph of the function s displayed to the right. when t lies between 0 and 7 seconds, the function s lies between -3 and 9 meters. So the s-axis shown below is numbered from -3 to 9 meters. From the calculations on the previous screen, the initial position of the particle is the origin. The particle then moves away from the origin with an initial velocity of -6 meters per second, which means it moves in the negative direction as shown in the diagram below. To review the above discussion, you should pause this video now. Part C. Find the position and velocity of the particle after 2 seconds of motion. Is the particle moving towards the origin or away from the origin? The position of the particle can be found by setting t equals 2 in the position function shown below. So st becomes s2 equals t becomes 2 times t becomes 2 minus 6 times cos t becomes cos 2 equals 2 times 2 minus 6 becomes minus 4 times cos 2 becomes minus 0.416 equals 2 times minus 4 times minus 0.416 is 3.328 meters. The velocity of the particle can be found by setting t equals 2 in the velocity function shown below. So s-t becomes s-2 equals 2 times t becomes 2 minus 3 times cos t becomes cos 2 minus t becomes 2 times t becomes 2 minus 6 times sin t becomes sin 2 equals 2 times 2 minus 3 becomes minus 1 times cos 2 becomes minus 0.416 minus 2 times 2 minus 6 becomes minus 4 times sin 2 becomes 0.909 equals 2 times minus 1 times minus 0.416 is 0.832, and minus 2 times minus 4 times 0.909 is plus 7.272 equals 0.832 plus 7.272 is 8.104 meters per second. So the particle starts 3.328 meters on the positive side of the origin and moves away from the origin in the positive direction with a velocity of 8.104 meters per second. To review the above calculations, you should pause this video now. Note that using the TI-84 calculator, cos2 equals minus 0.41623D and sin2 equals 0.90923D. Part C. Diagram of the S-axis. As in Part B, the position and velocity of the particle will be plotted on the S-axis, which is shown below. From the calculations on the previous screen, after 2 seconds of motion, the particle is 3.328 meters to the right of the origin, moving away from the origin in the positive direction, with a velocity of 8.104 meters per second. To review the above discussion, you should pause this video now. Note that the particle moves away from the origin when the position and velocity are the same signs, and the particle moves towards the origin when the position and velocity are opposite signs. When solving questions from your textbook similar to the example in this video, you must first find the derivative of the function in your homework question using the appropriate rules before proceeding through this video. See Part A. Use Part B to find the initial position and the initial velocity of the particle, and to show whether the particle moves away from or towards the origin. Use Part C to find the position and velocity of the particle at a given time, and to show whether the particle moves away from or towards the origin. If you wish to include the diagram in parts B and or C in your solution, you can find the values you need to draw the s-axis by graphing the function s on the TI-84 calculator. See Part B, diagram of the s-axis. If you follow the above instructions, you should find this topic simple and beautiful. Cheers! Do not forget to check your answers with the answers in the back of the textbook. Reminders displayed as a reference without commentary. To review the above reminders, you should pause this video now.